Right, okay, guys. So in our previous video, we have already discussed the five-state process diagram, and I have discussed them in detail. So today we are going to look into the seven-state process diagram, right? Seven-state process diagram, right? So if there is any student who is watching this video without watching the previous one, I request you first you watch the five-state process diagram. After that, you watch this, right? You can find it in our YouTube channel, right? So when it comes to the seven-state process diagram, let me explain that. So here, first of all, we are going to have the new state, right? New state, right? Now we'll imagine in our hard disk we have a program called MS Excel, right? There is a program MS Excel, so you guys know that is in the hard disk, right? Right. So we call this as new. The process is about to begin, right? Before beginning, that is new state. The process has not already begun, right? It is about to begin. So we called it new state, right? Before beginning, not yet uh, begun. Is the process is about to begin, right? So that is where it is new state, right? Now new state is in the secondary memory, right? Right now, in our previous video, we have discussed this, right? From the new, it will come to the ready, right? So the purpose of any process is go to the running state to get executed. But we know all the processes cannot go to the running state directly because our CPU can process one process, right, at a time. So therefore, first of all, it must go to the ready state, right? It must go to the ready state and it must wait in a queue. Then our scheduler will decide whether to dispatch it based on priority based or first come first serve based, right? We will be learning scheduler in our future sessions, right? And here what will happen, so from the new state the process will get admitted to the new ready state. Now this ready state is in the random access memory, right? The primary memory. It will get admitted to the ready state, right? So we call this admit, right? Now from the ready, then it will go to the running state. From the ready, it will go to the running state. Running state. So which process to be sent to the running state will be determined by our operating system. The scheduler will decide that, right? Because in the ready state, there will be a queue. So which process should be dispatched from the ready state to the running state will be decided by the operating system, the scheduler. We will be learning the scheduler in our future session, right? So we call this dispatch, right? Right now there will be it in the running. So next it will move to the terminated. We'll imagine that the process is not going to face any problems, then it will get terminated, right? Right. Terminated, you can call this state terminated. So here we can mention terminate. So if you take process, right, to be executed, certain time will be allocated for a process in the CPU to get executed. If that process is taking more than the allocated time, then it will get due to the timeout, it will again from the running state, it will move to the ready state, right? This occurs due to the timeout. Right. Imagine the process is in the running state, right? And it is waiting, still it didn't meet some input output requirements, right? It is facing, still it didn't meet the input output requirements. So then it will move to the block state. It will move to the blocked state. Why it is coming to the block state? A process is in the running state, but due to the as because it is not meeting the input output requirement from the running state, it will get moved to the block state, right? We call this IO event wait. IO event wait. Event wait. Now, why now this? If you take this ready state, the ready state is in the random access memory, running also in the RAM, blocked also is in the RAM, right? Now, why this process came from the running to the block? Because of the IO event wait. Now, we'll imagine that the process has met the input output requirements, right? So now it will move to the ready state back, right? It will move to the ready state back. So we call that as input output event completion. IO event completion, right? Right. Then now we know this ready, running, and blocked. All these three states are in the random access memory, the primary memory. Now we have already studied that in our random access memory, the storage capacity is, we don't have much storage capacity compared to the secondary storage. Now, in this block state also, what will happen, guys? In this block state also, there will be many processes, right? There will be many processes will be there waiting for the input output. Therefore, there will be many processes in the block state. So, as a result, what will happen? The RAM will be facing a storage capacity issue. Therefore, maybe sometimes even a high priority process cannot get cannot get admitted to the ready state. Why? Because there is no enough space in the random access memory. So now what our operating system does is, now there is a new state coming into the play, that is suspend and blocked. That is suspend and blocked. Now this suspend and block is in the virtual memory, right? Now I have already covered a video in the virtual memory under the memory management paging. So if you guys have missed that, watch that, right? It is in our YouTube channel, right? So what will happen? It will come to the suspend and blocked, the secondary memory, right? Suspend and block, right? Suspend and block. So why it is coming to the suspend and blocked state? Because in the blocked state, there are many processes, right? There are many processes in the block state waiting for input output requirement. Still, they didn't meet the input output requirement. Therefore, in the random access memory, I told that we have a compared to the secondary storage, we have a less capacity, storage capacity. Therefore, even high priority process cannot move from the new to cannot get admitted from the new to the ready state. Therefore, what our OS does is, it will move the it will move from the block state to the suspend and block, right? So if we call that as suspend. We call that as suspend. Suspend. Right now, this block state, right now, what we are going to do, now we'll imagine that the process that is in the suspend and blocked, right? The process which is in the suspend and blocked now has met the input output requirement, then most of the students will say what? Then now it will go to the block state. No, it won't go to the block state. Why, guys? Because what processes will be in the block state? The processes which are need to meet the input output requirements only will be in the block state. But once a process has met the input output requirement, it can't go back to the block state, no, right? Then it won't go to the ready state. Then it will go to a state called ready suspend, right? Ready suspend. Ready suspend. Right. Let's see. Ready, suspend. Now this ready suspend is also in the secondary storage. Ready suspend is also in the secondary storage, right? Then from the suspend and block, it will move to the ready or suspend. So now the reason why it is moving from the suspend and block to the ready or suspend, because IO event completion, it has met the input output requirement, right? So here you can say IO event completion, or you can say occurs completion, right? Now if you see this, right, if you see the block state and suspend and block state, now almost both of these are the same. The difference is the block is in the random access memory, the primary memory. The suspend and block is in the secondary memory. That's the difference. And if you consider this ready state and ready suspend state, these two are also almost same. The difference is the ready state is in the primary memory and ready suspend is in the secondary memory. Right? Right. Then what is happening now, the reason why the process came from the block state to the suspend and block state, because there is no enough space in the random access memory. Now it has once that process has met the input output requirement, it can't go to the block state, because what processes will be in the block state? The processes that ha haven't met the input output requirement. Now once a process has met the input output requirement, it must go to the ready suspend state, right? So here we call that IO event completion. Now we suppose now in the random access memory, now we have storage space. Then what will happen? From the ready or suspend state, the process will move to the ready state. We call this as admit. We call this as admit, right? Admit. I hope this is clear, right? Now suppose in the random access memory, now we have storage space, right? Now we have storage space, right? So then what will happen is, now from the suspend and block state, the process will move to the block state. From the suspend and block state, the process will move to the from suspend and block, it will move to the block state. We call this as admit, right? We call this as admit. Now I know you guys will wondering why it is moving from the suspend and block to the block state. We are having enough space in the random access memory. It is moving from the suspend and block to the block state, because the reason why it came from the block to the suspend and block, because no enough storage capacity in the primary memory. Now as with random access memory, now we have enough storage space. It is moving from the suspend and block to the block state, right? Because you guys know when the processes move in the secondary storage, the speed is less. The speed is less. But when it is moving in the random access memory, when the processes are moving the random access memory, the speed is high. Therefore, it will increase the efficiency, right? Because if you are keeping the process in the suspend and block state, even after having enough storage space in the random access memory, it will reduce the efficiency, because we know in the secondary memory the processes will move slowly, but in the random access memory the processes will move faster compared to the secondary storage. Therefore we admit the process from the suspend and block to the block state, right? So once that process meets the IO event completion, it will go to the ready and then to the running, right? Right. Now in the ready state, right? Now in the ready state also there will be what? There will be many processes. As because the capacity of our primary memory is lower, right? Limited and lower compared to the secondary storage. So our RAM capacity will get filled. Therefore, even a high priority process cannot get admitted to the ready state. Then whatever operating system does is, it will move some processes from the ready to the ready or suspend. This moment we call suspend, right? Suspend. We call suspend. right. Now a process can also be moved from the new to the uh, ready or suspend, because let us suppose there are in the random access memory. Now the storage capacity has been full, right? The storage capacity is full, and also the process that has been created is a less priority process. So moving it from the new to the ready, therefore we need to swap, and we need to change the states, and we need to suspend and swap them. Therefore, without doing that, as because it is a less priority processing system will move it from the new to the ready or suspend, right? So now let us look it from the beginning again. So once a new process is created, it will get admitted to the ready state. Then from the ready state, our scheduler will determine which process, because in the ready state there will be many processes, which process should be moved to the running state, right? We call that as dispatch. So if that process gets executed without any problems, then it will get terminated. There will be some sort of time allocated for a process to be processed in the CPU, right? So if it is taking more time than the allocated time, it will move from the running to the ready state. We call this as timeout because of the timeout. And suppose the process in the running state, if it is waiting for an input output, so it will move from the running to the block state. It is, we call this as IO event wait. And in the block state, once the IO, if it meets the IO requirement from the block, it will move to the ready state, right? So we call this IO event completion. But in the block state, suppose if there are many processors, I have told you that in our random access memory, compared to the secondary storage, the storage space is limited. So when there are many processors, whatever OS does is there will be some less priority processors waiting for IO. So then it will suspend from the block state to the suspend and block. Now the suspend and block is in the secondary storage, right? So once that process meet the input output requirement, it will move from the suspend and block to the ready or suspend. Now this one we call as IO event completion. Now you should not think that it will move from the suspend and block to the block state. Why? The what processes will be in the block state? The processes which are waiting for IO events will be waiting in the block state. But if a process has met the IO event, then it can't move to the block state, it must move to the ready suspend, right? So this ready suspend is also in the secondary storage, right? Now suppose if a event has moved to the suspend and block due to the storage issues in the primary memory, but now if there is storage space in the primary memory, then we can move it from the suspend and block to the block state, because the reason is the reason why it got moved from the block to the suspend and block is what? Because there is no enough space. Now it has enough space, then from the suspend and block it will move to the block state, because I have told you in the explanation, the movement of processes in the secondary storage is slower compared to the primary memory, right? And also right, that is the reason. And once it met the IO event completion, it will move to the ready state, right? Now suppose the process is waiting in the ready or suspend state, right? Because the process got moved from the block to the suspend and block due to the storage problem in the random access memory. And suppose that process got the IO event completion, then it will move to the ready or suspend. And in the ready or suspend, suppose now if the random access memory got storage space, then from the ready or suspend, the secondary storage, it will get admitted to the ready state, the random access memory, right? Right. So this is the end of our seven states process diagram. So I think it's clear. And also a new process, when there is no enough space in the random access memory, let us imagine the new process is a less priority process. Therefore, it can get admitted to the secondary storage where the ready suspend, right?